Okay, so now briefly returning to data. Well, we've created graphs of data. That is probably one of the main functions that we want to do. But we also often need to take transformations of the data. There are already some here. Like RPI seem to be a combination of two variables. It doesn't say how the older data was reconstructed, but the data were spliced together basically. So at some point it's the same as Shaw. Where does it start here? See here, it was the same as the Shaw variable, the RPI variable. But before that it's spliced together from that CZBH series, which has a different reference date. So the first thing, let's assume that we've constructed that RPI. Then the next thing we may want to do is take the logs or do something like what was done in inflatQ. So 400 times the first difference. Maybe we can do that. And to do that, well, simple transformations. So if we do want to take transformations like LRPI or inflatQ of RPI, the most convenient way to do that is using the calculator. In the calculator, we write expressions and then we click on the equal sign to evaluate them. So say we want to take the first difference of the logs of RPI, and we can select the variable in the database, click on dlog. Dlog is a function that is there, and then we click on equals. And then we have DLRPI is a proposed name. You don't have to use that, but that is what D for first difference, L for log, that is what OxMetrics proposes. Another way of doing it is to first take the logs and then the first differences. So if I clear the expression that was built here, if I now select LRPI and difference, then I specify the lag length and I can take the first difference of LRPI. Notice that the lag function is available too, but we tend not to take lags in the database because that is done as part of the modeling. Click on equals, accept the proposed name, and now it's listed in the database and you can plot it. Of course, it's very similar to inflatQ except for the scaling. So that is a calculator. What the calculator does is, if I go back to the results window, it writes the algebra code for the transformation that I just took. So I could copy that or edit that and rerun it, for example. So I could say, if I made a mistake and I just want to call this Z, then I can rerun this line as algebra code. So I click on run, selection as algebra, you see the shortcut there as well. And now I've created a variable called Z in the database that is listed at the end, which is really the same as DLRPI. So I could have just renamed it as well. As you can see, there's a star in front of the name. That means I've made changes to the data file, and the data file that is loaded is not the same at the moment as the one that is stored on the computer, but as soon as I hit save, it will be the same. There's also undo and for the changes. So if I really didn't want to do that, I just click on undo, and now I'm back. The star is gone. I'm back to the original version. So that is the data and the graphics. The assumption is that the data are available. We always like to look at the data, to learn about the data, and to find out what mistakes in the data before we start modeling. But then when we start modeling, of course, the graphics is still a very important aspect of evaluating what we're doing. So the next stage in this would be to look at some of the modeling modules that are available inside OxMetrics.